Hey everyone, we're going to continue with our hypothesis test with our second approach, and that is using a t-test of significance. So we can compute the statistic t equals b1 hat minus our hypothesized value of b1 divided by the standard error of our estimated coefficient of b1. And what we're trying to do here is we're trying to compare the absolute value of the t statistic with that of the t critical value. And we're actually going to get the same result like we did above with a confidence interval approach. And so the idea is if the absolute value of t is greater than the t critical value, then we can reject the null hypothesis. So let's actually just substitute the values that we've already obtained. So we have our results dot params, and we're going to look at our estimated coefficient of b1. That's 1.26. And then we're going to subtract that from our hypothesized value of b1. And remember, that is just 1.0. And we're going to divide that all by our standard error of the estimated coefficient. So that's results. It's going to be divided by results dot BSE 1. And we get 0.954. And remember, since 0.954 is smaller than our t critical value that we computed up above of 1.99, we cannot reject the null that b1 equals 1. So this statement is equivalent to saying that we are 95% confident that the interval for the slope coefficient does contain the value of 1. Note that this approach is the same result as our confidence interval approach. They both do not allow us to reject the null hypothesis. Something interesting to note here also is that the standard error of the estimated coefficient, it's very important in our input for our hypothesis test, because the stronger the regression results, or stronger regression results lead to smaller standard errors of the estimated parameter. And therefore that results in a tighter confidence interval and also a larger t statistic. I also want to state that if we look at our results, we get a t value, and this is important to understand. We get a t value for our slope coefficient of 4.616. But that's because we are using a null hypothesis of 0. We are testing a null hypothesis of 1. And so we can actually see how they obtain that value by just taking our same formula here. And instead of subtracting by 1, we subtract by 0, and we should get 4.616. So again, let's summarize our conclusion from these results. Since this value of 0.95 of t is smaller than our t critical value of 1.99, we cannot reject the null hypothesis that beta equals 1. And remember, this is equivalent to saying that we are 95% confident that the interval for the slope coefficient does contain the value of 1. And therefore, this implies that Apple does have an average level of market risk, or equivalently saying its required return in excess of the risk-free rate is similar to that of the market's required excess return. So if you like this video, please subscribe. In our next video, we're going to talk about ANOVA, or analysis of variance, using the f-test, which will help us test the hypothesis of the entire equation, of all the coefficients in the equation, and if it's equal or not equal to 0. So till next time, thank you.